Okay, I'm going to quit talking. I will hang around, and if there are more questions, we can answer them later. But hey, Aleksey, I'm going to turn this over to you. My former colleague, Aleksey Studnev from BitQuery is going to take it away and talk about GraphQL for analytics. So go for it, Aleksey.
Yeah, thank you, Robert. It was wonderful to listen again about how ClickHouse is great. So, and actually, our company started with ClickHouse because Alexander Zaitsev recommended me to use the ClickHouse for the task of indexing the blockchain. It was at the end of 2017, I believe, when ClickHouse wasn't so major as now. But I think this decision defined like 50% of the success of our company, because we were ahead of competitors who used like Elastic or Postgres or other solutions. And I would thank, of course, thanks to Alexander for this recommendation. We founded the company called BitQuery, and it's dedicated to the blockchain analytics, but today I'll focus just on one particular technology that we use. We use GraphQL for analytics on top of the ClickHouse, and I will explain why we're doing that, why we did this choice, how we manage this. We will have the short demo. Then also, I will show you some internals of the functionality and talk about some future plans, how we see it in the future. So using GraphQL for analytics is not very like mainstream, right? So probably didn't see it before. And we don't see any examples, and that's why actually I'm talking about this one right now, because it's not standard solution. It's kind of questionable, but we have a rather positive experience till now, and I want to share that. So what we're doing, we reading the data as events from different blockchain networks. And it's a rather standard ETL process which doing this. We don't use yet Kafka, but actually we're planning to migrate this process to Kafka pretty soon. We store all the data in ClickHouse in many tables. And these many tables is one of the issues that we have. So why we have many tables? First reason is natural, because blockchains are different. We now have approximately 40 different blockchains like Ethereum, Bitcoin. Some of them similar, but most of them are rather different. And we cannot just physically place everything in one table. It doesn't make any sense. The second reason is what Robert mentioned, is materialized views and aggregates. So of course, you need to use it because we have a runtime performance, which is critical for us. From one table, we immediately get 10 tables or even more. And so it multiplies. So I don't know the exact number of tables we're running now, seriously, but it's above 200 or maybe 300. I cannot count them. They grown pretty fast, and it's just a big zoo of tables. But when we come to our clients, we want to present ourselves not as a 300 tables, but as the API, which is easy to use, and everyone actually can query some information from blockchain. Actually, our business is based on the fact that the blockchain is rather hard to query for analytics. It's so designed. So it may be good designed for query for one particular transaction. It's like MySQL, but it's pretty hard to like answer the question, how many Bitcoins is traveling every day? What is most active addresses on the blockchain? What is suspicious activities, like abnormal transactions? What smart contracts are most popular? So many questions that we can answer with using ClickHouse aggregates. But it's very hard to answer if you don't index the data. And we have free public tier. We have also the subscription tier, like SaaS model. And also sometimes we install the dedicated systems. But in all cases, we have the single API that's used by applications. It's front-end applications, back-end applications, different kind, mobile even. So they use the same API. So this is our like business. This is very high-level view. So from left to right, maybe we skip it now. So what exact problems we have when talking about API? First problem that I said, that we have too many instances of things. So we have blockchains, schemes, tables, aggregates. For example, if you just want to query for some easy thing, you need to know all this stuff. You need to know where the table, so first of all, you need to know what scheme to query. You need to find this on particular cluster. You create this SQL query to it. You need to know which dictionary to use, how data is encoded. You need to select which particular aggregate or which particular materialized view to use. So for each particular query, you may select one or other depending on performance optimizations. So you need to know too much things if you just want to query. And in our case, it's just unacceptable to show this to clients. We even very tentatively give them the schema if they ask only. We try not to give them the schema of the database because it's hardly manageable in our SaaS model. But we want to have one API. We want to have the single point when client can easily use HTTP or some REST API and to easily query the data. And actually, we started with very easy queries. So people asked us particular data, and we created, every time we created new endpoint. And it's very fast. We met with the scalability problems of just our development. Because it multiplies on the number of blockchains, first of all. So for one blockchain, you implement this method. For another blockchain, you need again implement this method, and so on. So and it multiplies on the complexity on the physical clusters. So you need to find a particular table and cluster. So you can imagine that this very fast it's just unmanageable situation when you want to implement like every feature manually as an API. But also the clients need different fields and different joins. For example, one client needs join with market data for Bitcoin. He needs to know in each transaction, he needs to know what was the price for Bitcoin. Another client wants like additional fields which were not added. And this also, like if you add all these requests in your API, the API will grow. So you will fastly like come up with all the fields that all clients require. So completely unmanageable. So that's all these problems actually I just listed them to show that our clients actually do not want to make them think, but all this hassle lies on our side. And this was a problem from our side. And which solutions to this problem we considered? First of all, we can give them SQL. As I said, this meets with a scalability problem on managing all these tables, schemas, and supporting the SQL. If we allow our clients to run SQL directly in the database, we, of course, could consider making some kind of layer of views, common views. But even that will not solve all the problems because it's very hard to create the view which optimizes the query. because in one case it must read from one table, in another case it should read from another table. I know that say Vertica have something similar to this feature, but ClickHouse, as far as I know, it doesn't have. And this is very easy optimization. We have much more sophisticated optimizations like unions and joins sometimes. So it's very hard to present as views. View is not a programming like declarative kind of language. It's just SQL. Another thing which we consider is just continue to use HTTP JSON, but I already explained that it's easy to use by client, but very inflexible and very hard to manage. It's somewhere on the right side of this diagram. XMLA MDX. It's XML for analytics, and MDX. It's something Microsoft. And actually, in my previous company, we used this technology over Vertica, and it could be used with ClickHouse as well. But we, as I remember, we met with, it's not easy technology in terms of learning curves. So it requires some reading some materials, how to make queries. It has some concepts. So you must be professional in all AP programming to use that. That's not acceptable for us. Our clients are not typically, they're not typically like programmers of a lab system. They're just, most of them are just use our system with a bunch of other systems. We are just one of the row. We cannot force them learn that. And the last one is GraphQL. So we don't know where to place it here on the diagram because we actually don't know the examples of good usage of GraphQL over analytics, but it has some important features on the next slide that tentatively give us some hints that it may be good. It may be good. It was. Yes?
Aleksey, can I just insert a quick question? Is there an engine for XMLA to ClickHouse? Because I know you were looking at it. There was a question from the crowd.
I am not aware of that. I actually maybe I didn't hear about that.
Okay,
I didn't
thanks.
hear. But probably because it was even before. It was 2000, maybe 16. I don't remember the year. Or the previous company, we created the XMLA bridge to Vertica, and it works. It should work above any JDBC driver, so it can be connected to ClickHouse as well, I think.
Okay, great, thank you.
Mm-hmm. So what is GraphQL? GraphQL, it is generally the name of GraphQL is very confusing. It was, as I understand, it's invented by Facebook to query like friends. Say if they show their page on the Facebook, they want to query not just your name and picture, but also your friends, maybe some posts. And when you change the interface, you need to change the specification of data you need to query. But because Facebook need to optimize, then they need to create some query language which defines which particular data you need to show on the page. That's how I understand GraphQL was created. So it's not about graph. It's more like how to query data for browser. It's more about that. It's JSON query language. So if you need to query JSON, so probably GraphQL is the best way to do that. It has schema. Schema defines what you can query, and schema is very good. It creates self-documentation of your API first of all, so you can rely on that as a documentation. Also, it's validated on every query, so the query all validated. It's very useful. then it allows to build editors of queries that I will show you today in demo that just make it easier to build the queries, even if you don't know how to build that. It just forwards you in the right way. So schema is also JSON apparently, but schema defines what you can query. Easy. And by the way, it's more strict than SQL schema. It's more strict. It defines not just data types. It defines the structure. It defines data constraints. A lot of things. So schema is very specific about what you can query. And the idea is that you can query only what you need. So one application may query only one attribute from table, one column, say another will query 10 columns, and this will be the same API. And this is the power, this is main point of all this list, why we selected, because this is exactly our case. We want to query, in some cases, we want to query all the network. In another case, we just want to query one transaction. And we don't want to build API endpoints for network and another API endpoint for transaction. That's not what we want to build, because we come with this, we already passed this stage with REST that it's not a manageable situation. Also, GraphQL supports updates. They call it modifications, and also it's subscription model they have, but we don't use it now. Maybe in the future. And yes, it's not used yet for LAP, but we're going to fix that. So this is GraphQL, and let's go to some demo how it actually works. So first of all, this is a GraphQL. It's just off-the-shelf editor of GraphQL. It understands the schema, so it loads the schema from the endpoint. It understands the endpoint. This is our endpoint. And it shows it in the docs here. So you see the top level element, query, and here the elements that you can go to, say, Bitcoin network. It shows what options you have here. You can go here to the, sorry, it's not here. Yes. So this is fields that you can query, say blocks, coin path, inputs, so on. It's our specific schema, but it's the schema that I talk to you about. And this left is editor. So it has very nice feature of it context, understand the context. So the first I type query, and then I see the selection of types that I can use, and we consider this as you can consider this as a data set, your data set. So for example, I can query like Bitcoin, our data set. The next step will be inside the Bitcoin, you can query the cube. It's not exactly the table, because I will show you further that there can be many tables under each of these cubes. So for example, I select blocks, and then I select what I want to query. For example, I want to query the count of blocks. And I got the first like valid query. I can execute it, and I get the result. So it's the first like valid query. And as you see, what's very wonderful around that the structure of response is exactly the structure of query. So you literally define the structure that you want to get on the outside. So for, if you want to query, say you want to include here the year, you can add here the dimension year, and it will group it by year. So now you see it, the count by the year, and so on. So you can add here as many like dimensions. For example, block version. This is the version of protocol of Bitcoin, and you get here the block version together with year. And in all that cases, I get the result very close to the original query. So I literally define what I want to get, and I don't care about from which table it reads, from which like cluster, how I create the SQL. So we do it for on the back end. Also, what is nice, that I can add here another data set immediately here and compare, say, the same counts per year, say, for another chain, Ethereum. And it will return the, so it will return the Ethereum. So this query actually consists of two, and it reads from different tables, even from physically different clusters. But for what's important for our users, it doesn't matter. So they just use it as if it's like single entity. So how this can be actually used? So say we can create all these queries for your cubes. We directly can use it in the browser. That one option. So we have some demo explorer. For example, we have the data sets for different blockchains. Here we have the COVID data. And if you say go to the map, so this is example how I build this map. This map shows how many people with confirmed COVID exist today on different countries. So it has the simple query here, which we execute, which we create just in JavaScript in browser. We submit it to the GraphQL API. We can execute it here. It has the dimension, country, name, latitude, and metrics confirmed, death, recovered. And what's nice about that you can actually build an analytical system without any server. So yes, because this query is created in browser, it's executed in browser, it only submit the GraphQL to server and get back the results. But the programming of the query happens in the browser. That's very important. So you don't need any servers to compose your query, to manage your query. You can build completely serverless analytical platform based on that. Because typical approach, like what we see in MicroStrategy and on others, they have the servers that actually create their visualized like data for you, and this is very different from. This is much more lightweight from user perspective. And of course, you can get this query placed in your JavaScript application. It will work the same way as I'm showing you, no difference. Just place it on JS Fiddle, it will play the same. Like I can even do it very fast. I can just copy it from here, run JS Fiddle. The only thing for JS Fiddle, I have to separate here script from HTML. That's what I do manually, but everything else should be fine. So yes, I run it and I get it here. So, and you can combine, here you have the same query. This is the query to the data warehouse. So you can edit it here, like changing, like since you can change the date here, for example, there, or something else. So you can build serverless applications. Let's dig deeper. I will briefly explain what is this query is about, because typical lab set looks like this. It's minimum. So you need to have dimensions, filters, metrics. You need to have cubes and data sets. Actually, I've taken this approximately from XMLA model, but I know that lab systems work pretty similar to each other. In our case, when we have like, this is like more complex query. By the way, it queries, let me explain what it queries, because it's very practical thing. It queries the prices of trades on blockchain for different coins based on time interval for 5 days. And it calculates minimum price, maximum price, quote price, open price, close price. So it creates the so-called a candlestick diagram, which when you see. So this query completely built all the data for this candlestick diagram, just one query. And it consists from all these entities that I've shown. So first of all, it's the entity is dataset name, Ethereum in this case, the cube, it's DEX trades. It has dimensions, time interval, currencies. It has metrics. So what is the difference between dimensions and metrics? Actually, there is very small difference. And interesting that XMLA considers metrics as just one dimension, just one additional dimension of special type. And I kind of agree with that. But what's important to see that typically metrics are numeric and they can edit calculated maximum, minimums. Typically, they behave somehow differently from dimensions. All these entities are in this query, and also filters. Filters allow to limit the scope of query if you need it. So dimension, how I understand it in GraphQL. First of all, it is of course defined, all dimensions defined in schema. So you have a drop-down list of them when you create a schema. But it also have so-called attributes. So attribute means that sometimes you need just symbols of currencies, sometimes you need addresses, and sometimes you need different aggregations of dimensions. So attributes, you can consider attributes as sub-dimensions. And the level can be not just one as here, but it can be more than one. So you can have dimension, then you may have attribute, and you have attribute of this attribute, and so on. So it can be as deep as you need it. And you can query on every like level of this structure. Also, we call so-called function here. Actually, GraphQL names it attributes. When you look at GraphQL specification, these brackets are called attributes. But we put special meaning in that. We consider that in this count, the day has function count equal to 5. It means that it's like a specification of what you need to query. Another example is format of, say, date. You need to have dimension formatted with formatted date. Another example is in which currency you need to have the result. So we have a lot of usage of these functions in different way. We call them functions, while I said in GraphQL there's no such thing. And we found it's quite useful because you cannot define everything. You still need to leave some kind of programming inside the query. So this is our programming model, what I'm showing. And this is our like understanding how GraphQL can be mapped on analytics. Any questions? Do we calculate metrics on our backend in advance or use aggregated tables for that? Both. It depends on optimization. I will talk about like in 5 minutes about that in more details. But the answer is both. Depending on the query, yes. And another question, when the query is converted, I'm assuming you are doing aggregation. Do you aggregate only over the listed dimensions? I would say that ClickHouse doing aggregation for us, not we, because we compose the, ultimately we of course compose the SQL statement for ClickHouse. And there is definitely group by there, and ClickHouse makes an aggregation in this case.
Hi, Louis here. Thank you
Yes.
for your answer. So, okay, I was just curious on this because when I did an implementation with group by and a dynamic dimension, we had some caching issues. So some clients will cache the GraphQL query based on what's provided. So we had to pass the dimension that were in the group by as a function. So I don't know if you had a similar issue or something like this, but
oh yes, by the way, I didn't mention that really some GraphQL clients, some of them have caching function, but we turn it off.
Understood.
Mm-hmm. And also the question you asked, is the dashboard displaying GraphQL or a custom page, or is it Grafana? I would say JavaScript. So it's yes, it's a custom page that you create using JavaScript, where you place just calls to GraphQL with this endpoint, and you can create this JavaScript in any framework that you need. It's not Grafana, of course.
Thank you.
Mm-hmm. The next one is metric. What we understand as metric. As I said, we consider it some numeric, but also in many cases, it's not just enough to define that you have like count. You need to specify it in more detail. So we again use these attributes as functions. So we have metric. We have the alias for metric. Sometimes we need it, and also we have the function which defines which particular formula we need to apply when we calculate. In this example, another example below is minimum of block get quote price. It means that we want to have the quote price for minimum of all block in the aggregation. So here we get open price. And again, we using the attributes as function. So literally, we consider this line of code as give me minimum and apply function of with argument block and function get with argument quote price. Internally, it works like this. But in GraphQL queries, it even can be read as like sentence. Minimum block get quote price. It's as natural language. It's kind of fun. And what is under the hood here? As I said, there is no, at least we didn't find any implementation of this. So we built our own, which is not very hard. So a GraphQL library, it is in every programming language available. We selected Ruby language just for historical reason. We have more than half system built on Ruby and Ruby on Rails. And we added like special library for so-called ActiveCube, because Ruby on Rails has active records. So we created the library called ActiveCube, and ActiveCube converts queries from GraphQL to queries to ClickHouse, to SQL, essentially. But it cannot do that just automatically, because it doesn't understand how to do that, and we need to explain. And the explanation is cube definition. And let me show how it looks like very briefly. The cube definition is the code, essentially. So for example, this is cubes. Let's open some cube here. So the cube defines which tables it can use. So in this case, it can use 3 tables because one table, say, optimized by one criteria of order and another by another one. And if we don't do that, then we will not get performance that we need. And this ActiveCube, when it doing the conversion to SQL, it of course knows all the attributes of the tables, and it makes a query depending on like which field need to use as potential index. Then it has dimensions, so it defines here the dimensions which we can use, metrics that you can use, and the filters, and that's it. So basically, this is a cube. The schema is generated from this. Also, the SQL is generated from this. So this ActiveCube looks at this definition, and it understands like what it can use for which particular like query. It selects dimensions, it selects metrics, it composes SQL for the tables that defined here. So in brief, it works like this. Yes, it's in Ruby, and it's not. It's open source. ActiveCube is open source gem, and it's evolving. So I would not say that it's very stable because we constantly add in some new features there. But we use it in the close to production system right now, and that's works pretty good. So let me overview what we get from all this. So we think we built rather easy to use tool set, first of all, because how we detect that? Because we have, say, Telegram channel where people playing with the system, they posting these GraphQL queries back and forth like every day, and we don't have any documentation, by the way, nothing. Like we have some blog posts which describe some examples, but we don't have any like book of documentation where describe how it's used. So people using it without reading it, and it's a good sign. So of course we need to write documentation. I know that, but it's development goes like faster than the pen, as always. The other thing is important. There are multiple off-the-shelf tools for GraphQL editing, schema composition. I mentioned here Observable HQ and Postman as a startups who make some kind of environments for using this kind of APIs to embed it into the. I can briefly show you, by the way, the Observable HQ. By the way, it's a great tool. If you never tried it, you should, of course, try it. We built a notebook there just to demonstrate that we can embed the query here. This is the query, and it builds these graphs. When I load a page, it actually queries the data warehouse, returns data here, like, and this is example of dashboard. And by the way, it's example of this serverless architecture of analytical system. So you can consider this Observable HQ as a very simple analytical system that we converted into this dashboard. Right. API-ready solution for SaaS client. We convert our clients very soon to this GraphQL API. They're pretty happy with that already. So we make deprecated REST HTTP to GraphQL. And we have projects, of course, and plans. First of all, we need the help from community because unlike REST API, people can build own queries. That's very important. They can build own queries, share that. We already try to incentivize that, not by money, but by attraction and attention to what they do in. So build a community is our plan. Also, technically, we have a lot of enhancements that we need to do. We plan to have the so-called flexi graph, because the schema right now is very, I would say, rigid. But we need to have a flexible schema where anybody can define what he can potentially query, and that needs some. This is a layer above the current system, like the function of a schema. We have a big demand on that. For example, one use case for that is ability to query different data sets and combine them into one. That's a very evident example, which is pretty hard to do right now. If you try to find the ready-to-use solution, it's not as easy. Another thing, we need complexity estimator. That's, by the way, very important feature for every project of analytics. So you need to estimate the complexity of the query before you execute that. Resource management, measurement. So we need to measure how many resources we spend. So estimator estimates this, but we also need to measure. And we also go into enhance our ADE and dashboard builder, which I briefly shown you, to make the query building as easy as possible. So thank you. If you have any question, please post it or speak up. This is our website. This is our email, and if anybody is interested to contact them, we'll be very happy in helping you maybe answer questions or using this technology. Thanks.
Hey, Aleksey, that was an awesome talk. Thank you so much. So I don't see any pending questions right now, but we can hang around for a bit to answer questions on this or any other topic regarding ClickHouse. I think in politeness to Aleksey, if we have further questions on GraphQL, I'd like to take those first so that Aleksey can go to bed at some point, assuming you do that. So I think one of the questions that was sort of on the chat was, is there an open source library to resolve the GraphQL queries to ClickHouse SQL queries? And there just isn't. I mean, you guys have built this ActiveCube. That's sort of is that the correct answer? Yeah. This is GitHub BitQuery, and this ActiveCube is somewhere here. Yeah. Here is it. There are several libraries, ActiveCube and ActiveCube GraphQL. So they have some documentation. Maybe, I didn't create it like a big technology. So probably it needed my help if somebody will actually use it. But I will be happy to help. So yes, it has some examples and. Cool. I had a question. It was interesting that you had the integration with Observable. Does Observable also go directly to ClickHouse? I'm just curious if given that you've worked with it. Yes, it can. Oh, yes, it can. Yeah, it can through HTTP. You can create an Observable. Got it. Yeah, of course. Yes. The example that I showed use GraphQL, but you can use HTTP with SQL. Did you have, just given that you're familiar with Observable, did you feel there was, what did you feel was a trade-off of using GraphQL versus going straight in with an HTTP request? Oh, the main, so from Observable point of view, there is actually almost no difference. Yes, but the difference appears by the fact that you open your database to the world.
which we
Got it. Right.
not willing due to many reasons which I described.
Yeah.
And I know that many people also will not wish to do that. But still they need to expose some kind of interface to open world. So the question, what will be that interface?
Right.
Mm-hmm.
Great. Any other questions from the crowd? Once again, great talk from Aleksey and from the BitQuery team. Okay, well, hey, I think if there aren't further questions, I think we might call it a day here. I'd like to thank Aleksey again, once again for doing this great talk. This is the first time that we've ever had anything on GraphQL, and I just really appreciate you sharing what you've learned at BitQuery.
Yeah, thank you for inviting me. It was a pleasure to talk in your company.
Yeah. Great. Well, then what I'm going to say is we'll see you. I hope you all have enjoyed this meetup. We'll be doing another one on the 20th of January. Definitely sign up. Come bring your questions to try and stump Milovidov, Zhuravlev, and Zaitsev. They will be our combined team of experts. So we'll see you in about a month. And happy holidays, everybody.